learning with respect to computer vision also we have seen that. Transfer learning for NLP, we have seen the different scenarios of transfer learning we have seen. So different domains, different data set, different languages, different tasks. So you can learn based on the transfer learning models. And we have seen that why we can go for why what is the necessity of transfer learning and how good it's compared with deep learning. We have seen that. And slowly we enter into the word embedding concepts. One of the shallow transfer learning models existing in NLP. So now I'm just starting with the next model actually. So the objective of this presentation is first I'll take 20 to 30 minutes to complete these two things, both the advanced word embedding models, BERT and then ELMO. Then we will see, we'll go to the NLP demo. Fine. So far we have seen that word embedding, whatever I explained morning, that is actually word to vec. It's called the word to vec. So I'll take the, that is called the word to vec. So it's the famous person, Thomas Michelot, introduced in 2030, actually word to vec. So after that, there is a model called GLOW. So it took 1 year. You can see here, January, it took 1 year for the next model to arrive. So it's a combination of neural network plus point-based mutual information. So it's called a GLOW, Global Vectors for a Word Representation. So 2013, 14, and the next model is from Facebook. This is from Stanford University, and this is from Google. This is from Stanford University, and this is from Facebook. So it addresses the problem of the subword information. Morning I explained about the subword information. So the drawbacks of word to vec. So that FastX addressed that. So that is a 2015, Facebook introduced the character-based model. FastX is a character-based model. And slowly people enter into the model called transformer. So this is the extension of attention networks. So now if you see that in a deep learning, now most of the papers, most of the research happening in the particularly in NLP, most of the research happening in the attention networks. So attention network means where I have to give attention. So the extension of attention network is called transformers. The multi-attention network is a transformers. So that's what we're going to see now. So this is a timeline of word embedding, how it's initiated, and then what is the status of now. So we can see that this GLOW and then word to vec called as a FastX transformers are called as a pre-trained models, or you can call it as a transformer. Not transformer, transfer learning models. So after the transformers, 2018 ELMO comes into picture, and the extension of ELMO is BERT. So the BERT is become very popular. There are a lot of extension, a lot of alternates, and a lot of what happened after once the BERT is introduced. So this 2008 is one of the milestone of the NLP research because of the introduction of BERT. Now most of the NLP tasks BERT is giving, BERT is attained that state of art research. You'll see that what is BERT and then the things. Okay, so BERT represents bidirectional encoder representations from transformers. As I said that the transformer architecture is nothing but attention architecture. So it's a multi-attention architecture. So in a sentence, you should know that where I have to give importance. In a sentence, you should know where I have to give importance. It's related to your problem. Sometimes if you are interested in a sentiment analysis, so you should know that which place says that emotion, which phrase conveys the emotion. So that's the reason why the attention networks are popular. So this is called as the NLP's ImageNet moment. As I said that even though the word to vec 2013 itself comes, people won't consider this as the exact transfer learning. So once the transformer enters, once the BERT comes into picture, then only people realized there is an ImageNet moment of NLP, and then this is the called transfer learning part. Okay, we'll see that. So these pre-trained models, so that the BERT models have been have the same impact on the pre-trained image-generated model. So that is the same in a computer vision. But in ImageNet, in computer vision task, in ImageNet, how people, maybe you are aware that how the ImageNet model they are designed. The ImageNet, when did that, so the objective of that, all computer vision, most of the computer vision, I can say, instead of all, I can say, most of the computer vision tasks, the objective is image understanding. You need to understand the image. So people used to say that computer vision means object identification, mostly based on object identification, but not only object identification. You have to say the semantic relation between the objects. So that is image understanding. You should understand that. Yesterday I have given an example. I think car with the person. Person is somewhere and then car is somewhere. Your job is not only say that okay, car is there and the person is there. You should say the relation, association, the semanticness of the objects. So that helps you to understand the image better. So for understanding image, when they created the pre-trained model, the ImageNet, so they have taken a huge amount of images, labeled images they have taken. They have taken the labeled object, they have trained the data set. So their objective is to identify the objects, to help to identify the objects in a new or unseen images. So here the problem is to collecting the labeled data. So somehow some 2-3 institutions work and then they come up with the ImageNet model. But now, what about NLP? So NLP, the BERT model, whatever we are using. So the advantage here is we don't want any labeled data. Label means if a text is there, if you are adding the sentiment, or if you are adding the category of that text, or if you are adding whether the word is noun or verb, if you are adding that whether the text is the graphs of the text, syntactic graph of the text, phrases, what are the phrases out there. So if you are not adding anything, then it's unannotated text. So this is actually, this comes under that. So there is no annotation required. There is no supervision required. So that is advantage of using the BERT in NLP actually. So we don't want labeled data. What we require is only a documents. So what we require is only a document, set of documents. So this is called a document. So number of sentences. I will align into number of sentences, then I'll go for the pre-training model. Okay. So here there is the statement says that Google BERT will impact 1 in 10 queries in terms of search results. So the search result, whatever you are doing, now you can see that last few years from 2019 onwards, the huge improvement in the Google search engine translation, all the products. One of the reason is the BERT model. So this is the architecture of BERT. So yesterday we have seen architecture of encoder decoder architecture. This is kind of a similar architecture. E represents an encoder, and you can see here this is the BERT. This is a proposed one. This is the BERT model. So at the time of BERT, there are other models like the GPT, OpenAI GPT model. So there now GPT-3 is there. But the objective of the GPT model is slightly different. The objective of the GPT model is in the generation. So this is also transformer, but it will generate sentences. So I think I'll have an example to explain today, just to show that in a demo how you can generate new sentences. Fine. This is a Elmo actually. This is the there's not a combination of two. You can say that. So you can see here that the main difference between the BERT and Elmo, both are same, but the main difference is the interaction between the nodes here. This one, here that is missing. So we have a encoder input, or this is the transformer, as you can consider its output. So you are using transformer here and using transformer here. Next two level transformer you are using. One is for input transformer, other is for to generate the output. Here you see that instead of transformer, you have replaced the LSTM. But if you see that Elmo comes first, actually before BERT, Elmo comes. So what people tried is first Elmo means this is the first architecture. Elmo come up with that LSTM LSTM was there, and then it's based on LSTM. This is LSTM model, but here the BERT replaces the LSTM to the transformers. We'll see that how the BERT is working. Yeah, so I'll just come to the BERT model directly. I'll just come to the BERT model. if you see that, so this is the corpus, the first step. You can see that you can call it as a semi-supervised training of large documents. So first you are going to develop the model. This is the model we're going to develop. The data set used is complete Wikipedia data, crawled Wikipedia data, and from Google Books. So these two model, these two data I have taken it as a, BERT modeling I have taken as a data set. So model is a BERT model, but architecture is there. What's our objective? To predict the masked words. So most of the NLP applications are related to the query whatever I asked. Morning I asked, I hided the word and then I asked what is that word. Same thing here. So the predict the masked words. You are going to mask some word. You are making a mission to predict the word. So parallel what you are doing, you are learning. You are teaching the machine to predict the word. So machine learns, once the machine learns, that learned knowledge you are taking out and then you are using it that as a language model or embedding or whatever. No. Fine. So this is actually the second step. Once we have a data set is ready and our objective is ready, we'll see that how the data set will look like and what we are going to do. This is a semi-supervised setting. It means that we are not using any labels here. I collected the data, that's it. But your objective is you want to do something. You want to, suppose you want to go for a, say, spam detection. Text is there means or email is there. You want to say that whether it's a spam or not. In that case, the second step you say that we have a supervised step where classifier is there and BERT is there. The BERT model, whatever you learn from the data set, this data set learned there, that can be used as such to classify the given text. Is spam or not spam. That's what we are calling it as the ImageNet model. So the text, whatever you want to find, whatever the text you are having to find out whether it's a spam or not spam will be given to this pre-trained model. You can see here examples for spam. So the term fields is there, spam. Win cash prizes, can say spam. So dear Mr., the exact person name is there. So it may not be a spam. Fine. Now we are going to, we have seen that how the BERT is used in a semi-supervised as well as supervised structure. And we'll see that the sentence classification with BERT modeling. So here also the supervised learning step is a sentence classification. Suppose you have a sentence and you are giving to the BERT and BERT is passing to the classifier. The classifier is saying that whether it's a spam or not spam. See the application. So you are passing the text to the BERT modeling. BERT, this is like a kind of feature extraction, you can see that. Then you're going for classifier, then it's a spam or not spam. Fine. So the most straightforward way to use BERT is to use it classify a single piece of text. This model would allow, this model would look like this. Okay, this is the thing actually. So their objective they have given actually single piece of text. Okay, so what kind of changes you can make in the BERT model according to the data set? So when the changes actually, when the BERT model, when you are developing the BERT model with the training phase, so you can change the BERT model with the existing data set input and so whatever having. So this process is called here fine tuning. So we used to say fine tuning the model because the BERT is trained for some other data. So fine tuning means you see here. The BERT is trained for book corpus and then keep the corpus. Now you want to apply a social media text. Suppose if you add this training, now BERT is, I can say that BERT is tuned for social media text. Am I clear? BERT is tuned for social media text. So this is the BERT architecture. You can see here the input, you can see that 512 input is there and 512 output. So first token, second token, like that. Okay, what the first token consists of? You can see here, the first token is a special token where you are adding some special symbol like a class. Because the BERT have the provision, even though we are saying that BERT is an unsupervised model, BERT have a provision to add annotated data also. So you can add the class here. If you don't have a class, you can put just CLS or you can add CLS. The corresponding class of the sentence. The sentence is speaking about sports. The sentence is speaking about medicine. The sentence is speaking about army. So these are the classes. Actually, the class you can add it here. Fine. Okay. The first input token. This is the first input token. Okay. So you can look at the size. You have 512 vector. So 512 vectors you are passing here. So each word you are passing, maximum word length 512. So each word you are going to get the vectors. So here as a output. Fine. Okay. This is the encoder of the transformer. So bird takes a sequence of word as input, and each layer applies the self-attention model. Each layer applies the self-attention. Please make a note. And process its results with the feedback network. What do you know that? And then hands off with the new loop. Fine. So the next step, you can see here, the class is there and vectors are there, and it's generating the vectors. The size of the vector is predefined in the BERT model. Here the size is 768. Size is 768. So that is our vector size. Each word will be converted into 768 vector size. Okay. So this is the 768 size, 768 size to vector. So this is the one case where you have pushing 512 words and then you are expecting 512 word vectors. Other case where you are pushing 512 words and you are expecting to classify the sentences into spam or not. In that cases, you can take this class information. Okay, this is the importance of class information. I hope it's clear. So you can see the word vectors are used for generating the sentence vector, but finally the cumulative vector will be like a classified vector, single representation of 768. Fine. The next popular embedding is that Elmo embedding. So that is Elmo represents the embedded language model. So we'll see that how this is addressing the problems of word to vec. See, for example, the guy is asking to Elmo, "Hi Elmo, what is the embedding of the word st?" So he is asking to that Elmo, what is the embedding for the word C? And Elmo is telling that there are multiple possible embeddings. Use it in a sentence. If you give a word, I cannot suggest. If you give the only the word, I cannot suggest the embedding. So what it is asking is you give it as a sentence because I want to know the context. Fine. So now what the Elmo is doing is Elmo making a sentence and then share it. Okay. So okay, here let's stick to improvisation in this skit. So now Elmo is playing. Oh, in that case, the embedding is 0.2, 0.32, sorry, 0.02, 0.16, 0.12, minus 0.1. This is the embedding. So you have given the sentence. In that sentence, the stick embedding is this one. Fine. Yeah, Elmo embedding you can see here. The words are there, and words should be embedded Elmo before, like it will be like this. And once it's embedded, for each word you will get a vector number representation. Fine. This is with respect to the English example. You can see here. Let's stick to embedding and LSTM. And this LSTM and embedding here, it's in the same direction. You can see here, and one more LSTM layer. So finally, the final output we are taking, the cumulative output we are taking, and we are giving to the embedding layer. Fine. So that is the softness here. You can see here. So embedding here, let's stick on to 3 words are there. We are passing through the layer 1, and from here we are going to layer 2. Sorry, not layer 2, the adjacent one. So here also we are going to layer 2. And finally, this will be generated. How it's identifying the word stick embedding? See here. So we have seen the architecture. This is a bidirectional model. That's what we are calling. It's a bidirectional encoder decoder. So the forward model, you can see here, the forward language model, how it look like. Let's stick to backward language model is, you can see here, again, let's stick to. So this embedding and layer 1, layer 2. This is the forward layer and this is the backward layer. This I already explained in the first few slides. So this is LSTM unit. I haven't covered LSTM. Just take this RNN kind of form. This is interesting one. The comparison of stick in the steps 2, second step actually. So after getting the output of the forward, so we also center where is the stick, center where is the stick, forward, backward, forward, backward. You can see here the forward language model, backward language model, the concatenation. What I'm doing here is the red color I'm taking, I'm keeping here, and the other colors I'm sticking here, the concatenation. So each output in each unit should be concatenated. After concatenating, so we are multiplying the mask vector. So mask vector to be multiplied. So after that, once you multiply that, you can see here multiply that, you're just taking a sum. So that is a weighted vectors. You're summing the weighted vectors. So that is Elmo. That is Elmo actually. You can see that each term is summing up and then taking. Now this is a final embedding of the word term stick. The interesting thing you can see here. So when I'm taking the stick embedding, I'm considering the first word and then the next word. In this way, the context information is appended here. That is the reason we are calling this as a contextualized embedding. So the remaining things are same. Whatever we have seen, the learning of this one and all, like how the deep learning is learning. But here, the one difference is when you're generating the embedding, what you're doing after generating the embedding, you're taking the other embeddings you're taking, each layer you're taking, and then you're concatenating, you're summing it up. So definitely the stick information, the information of LEDs will be here. The information of LEDs will be here. At the same time, the information of 2 will be here. They appended here because we are passing that information here. So that will influence us, that will give you the context embedding model. Okay. Now we'll just see that how we can use the same model for extracting the features. So we have seen that actually the fine-tuning approach of board. But the Elmo is as I said, that it's a contextualized word embedding. So the Elmo is a contextualized word embedding. So we can see here, I'll take one task and then I'll extract the features. I've taken suppose I've taken the name entity organization one task. So the same thing. So both sizes are there, 512 and 512, everything is there. Encoder, and 3 encoders. So each one you are passing. You can see here. This is your cumulative vector class. Help is there, help vector to first encoder, next encoder like that. Like that, you have 12 encoders. You just think about training. It's very difficult to training the model for the huge data set with our machine, whatever machines we need. Even GPU will take long time to train the model because the architecture having 12 layers, 12 encoded layers. So you can see here, each and every layer is 12 layers and then the outputs are. So people try to understand that we don't know which layers is giving good results. So they just come up with some kind of verification. So each layer is kind of how it's performing in each layer for the standard NER task. NER means name it diagnostic task. For the first layer alone, if I'm using embedding 91%, that is first layer, you can call it as embedding layer. First layer alone, if you are using 91. Second hidden layer. So the accuracy is, once you add the second hidden layer, the accuracy is 94.8. So second hidden layer plays the impact is more, 4% improvement. Sum of all layers. Again, it's increased 95.5. All 12 layers values I have summed up. Second to the last hidden layer, 11th layer I have used 95.6. See here, last layer, the accuracy is 94.9, but before layer, the accuracy is 95.6. But that is true actually. Some application it will happen because the 12 layers are, you have fixed the 12 layers, but no one is there to say the right number there. So that is based on your application. So the accuracy for the 12th layer is low, but the accuracy for the 11th layer is high. Now sum of last 4 layers. So I just have a feel that the last layers have the good information. So they just sum that last 4 values. You can see here 4 vectors, and they compared with the existing vectors. So the accuracy now it's 95.9, slightly increased. So instead of summing up, I have concatenated the 4 hidden layers. You can see here, the accuracy is 96. The accuracy is 96.1. So for 91 to 96.1. This is architecture with respect to applications. So the board itself, there are different architectures you can try actually. So one is actually sentence pair classification. Sentence pair means 2 sentences will be given. You need to find out that whether these 2 sentences are similar or not, or how much similar they are. So you can see here, sentence 1 can be paused like this. Sentence 2 next to the same architecture, and then learning team, finally class tables. Next one, single sentence classification. Single sentence you are giving, like fake news. Your job is to identify that whether the news is fake or not. Second one is single sentence. Third one, question answering. This is some of the tedious tasks. Question you are given, and you have answers actually, several answers. So automatically you are finding the answers from the components. You can see here. But the output here is the answer. The output means starting and then ending span of your data set, where the answer starts, where the answer ends. So the last one is related with sentence tagging NER. Actually, each token, each word we are taking. Sorry, each word we are taking and we are tokening. You can see here. Okay, now we'll come to the discussion, result and discussion. You can see here the accuracy of that model for the sentiment analysis task. So green color performing better results compared to all other models. Green color says a word bird large. There are different architectures also you can try, you can include in the model. So one is actually character embedding. So where if a language, if you feel that very complexity in a language, you can introduce character embedding. And combination of word embedding plus character embedding. This is the character, yeah, character annotations. Fine. Okay, same thing. Character embedding is a common. So the embedding architecture is fine, I think now. So we are using VLSTM character embedding layer. This is over a period of time. What are the other models are comes? As I said, that once BOT is introduced, BOT or ELMO, there are a lot number of models daily usually used to this release. Actually, some small modification. You can see here. So initially, each year only one model comes. BOT, then ELMO is 1 year to like that. But you can see here within a month, within a 3 month, they're getting within a 3 month, we're getting one new models. These models are interestingly, it's an extension of BERT model. Okay, so this is an important slide when you're talking about that BERT other models. So this will say about other models. You can see here ELMO other models are. So the ULM fit is for multi-language, multilingual, larger, more data. Fine. So these are the different variations of BERT. So the popular ones are Robota is a popular one, XLNet is a popular one, and GP2 and GP23 is popular one. Complex. Yeah, fine, that's it. So these are all the popular models of BERT. It's a comparison with the robot and distill BERT and XLNet. As I said, that this is a distill BERT and XL BERT or extension of BERT model. You can see the comparison. How much time will it take for training and how much of the performance, so that it's increasing or not. You can see here, compared to the BERT, robot was giving 20% improvement. Data 16 GB starts from 16 GB, 160 GB, and finally 130 GB XLNet. Fine. Okay, now we are coming to the conclusion. So before going to the demo, so I just to give some idea research directions. How can you proceed actually? One part is morning, as I said, that annotated embeddings. How post-tagging influences in embedding. How morphology influences embedding. How character embedding influences. Or joint embedding. So take a SIBO and stickgram. Take this SIBO and virtual SIBO and other embeddings. So and then try to develop a joint embeddings. Someone's video is on. Once again, I'll mute that and come. Fine. Fine. So that is other one is multilingual embedding or bilingual embeddings. So moving from one with the help of transfer learning from one embedding to other embedding. So we don't have embedding of Tamil. How can we make use of English embeddings? The next one is character vector model. Morning is it that morphological richness. So where it requires the character to width. Each character will convert into numbers, or each subword will convert into a set of numbers. And it's dealing with the code mixed script and Indian languages that will be used for Indian languages. For low resource languages, so we can go for parallel corpora. So we don't have parallel corpora, good parallel corpora. We can make use of English parallel corpora. We can generate our own parallel corpora in Indian languages. Fake news. Same case. Author profiling. So the next one, the author profiling. So where author profiling or hate speech are related to automatically profile the author from your history, from your text. I should know that I'm sitting. I mean, if you are in the anonymous place, so the system automatically should understand that based on your behavior or other patterns. So where you can use a text as an input here, and other parameters also your search history and everything can be as input. So these are all the link actually. So where I have referred for getting the details about the board and other things. So this is an interesting paper by Devlin about the board. So please make use of it and then use that. So, okay, this is my website. So if you have any questions, you can ask now. I'll go to the demo now. So there is a question from Bichumani. Sir, nowadays many article talks about COVID virus can use BERT model and question answer to extract information. Yeah, that's what actually yesterday also I have given the information about the COVID-19 data set. So people are trying for identifying the fake news. COVID-19, a lot of fake news are coming around that related to COVID-19. How to stop that or how to recognize that that particular news is fake news with the help of a BERT model. That is an interesting area of research. So that will be an interesting one if you develop. I don't find any question answering model with respect to COVID. That too, if you are building something with respect to Indian scenario, that will be too good. Yeah. So someone raised their hand. Kavita, you have any questions? Any other questions from participants? I'll move to the demo. So once again, I'll just open my browser. Okay. So I hope my screen is visible now. Is it visible, participants?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So the demo, there are two things I'm going to do in the demo actually. First, actually, I'm going to show some of the existing real-time applications of NLP. So the one motive is to motivate you to one agenda is to motivate you to build that kind of application for Indian languages. The other motivation is actually, as I said yesterday, no need to do anything from scratch. You can start developing from on top of it. Because when I saying about the embeddings, I said that there is no concept called annotated embeddings. So if you have a sentence, if you want to go for embedding, you can push the sentence to one of the tool, what I'm going to mention. There are open source tools also. You will get that information, linguistic information, let's say noun, verb, kind of information. Now you think your model to take this data to the transformer or any BERT kind of model. That will be an interesting one. First, I will take about the question answering demo. These are the existing demo actually. Okay, this is by one actually private company. So they are providing the services. This is a Pretrained Tech Lab, but not that good actually. But you can see here how it's working. But they don't have a system for. They are telling that they have a system for Hindi. But other language system they don't have. You can come up with our own system. That is good, I think. Fine. So if you see that we have paragraph is given, and then you can ask the question 1 and then question 2. And question 3 also you are asking. And you can see that you can submit and then you can check that. So it'll take some time. So it's running the board. This is the example of board question answering. So I hope you can remember you can remember the architecture also. I explained the question answering architecture. I'll quickly go to the question answering architecture once again. Yeah, this is the question answering architecture. So this is not a answer generation part. This is actually identifying the extract answers. We are not generating. We are saying that where the answer will start, where the answer will end from the given paragraph. So you can see here I have given something like this. And who is current CEO? System is telling that what is IPO? This is saying the initial public offering. I have given here initial public offering. So it's giving initial public offering. What is headquarters of Google? It's saying that Mountain View, California. It's given. The information are given here. So you can see here. I think, yeah. Now it's visible. I hope it's visible. participants?
Yes, sir. With you,
Yeah,
sir.
yeah. So Sundar Pichai was appointed CEO of Google, replacing Larry Page. So I'll just see that. We'll just check one question actually. So instead of is, I'll just say that who was the CEO? Suppose I don't know if the system will work or not. I'll just try that actually. And any other questions we can form from this? Something nicknamed Googleplex. We can ask the nickname of Google, no? Yeah. I'll ask one more question. The nickname of so you can see here an initial IPO offering took place in August 4 and Google moved the headquarters Mountain View, California, nicknamed the Googleplex. We'll see that. It's difficult to understand because Google and Googleplex is here. We'll see to it. In August 2015, Google announced plans to own various interest on okay. Leading subsidy fine. Alphabet interest. Okay. Any other question we can ask? Go. The incorporated Google was okay. Fine. This IPO, no. So suppose if you are not giving this IPO, if you are removing this, and then definitely system won't answer that question. So I understood the IPO. What is meant by IPO? If I remove this, it won't give. Since it is there, you can write a regular expression, and then they will add a rules like this, and then they'll record the information. So I'll see that under okay. These two questions we'll see that how the system is performing. So the paragraph, whatever paragraph you are giving, it should. Yeah, see that. What is the nickname of Google? It's giving Googleplex. Correct. Who was the CEO? I asked. So I expected the answer should be the Larry Page. So otherwise, who became the CEO of Alphabet? Okay, I'll just say that who is the CEO of Alphabet? The answer is Larry Page. I think. So headquarters already it's given answer. So one final try we'll check and then we'll go to the next name. It's a question answering system. This is based on the board. So you can develop this kind of systems. Yeah, here it's giving exactly Larry Page. So its knowledge is only from this text you are given. Okay, fine. So I'll go to the next one. Next demo. I'll share these things with you. Even if you want, you can also parallel. You can also check that. So anyway, I'll share in a. Anyway, I'll share this web links to you. Yeah, whether the page is visible from IBM Watson page is visible.
Yes, sir.
Fine, because sometimes it may not be loaded actually. Okay, so this is from the IBM Watson. So see that natural language understanding. So if you want to make use of it, you have to have an account IBM Cloud. This is a demo, so we are not having any. We are not using an IBM Cloud here. This is a demo, but you can build a custom model with the help of IBM Cloud actually. So here that you can see here the text is given. So given the text and then the URL is given, or URL or text you can give anything. So some sample text is given. I'm going to give analyze. You see that what is going to happen for this particular text. I'm going to analyze the complete natural language understanding analysis will come. You see here the sentiment, the overall sentiment that of the targeted content is given. So the overall sentiment is negative. And if you want the emotion, so see that emotion is joy is that 0.47 joy is there. So it's it says about some happy moment is there here. I lies buried treasure ship sailed through. So he enjoyed. I think so that's what it's saying that this is some statement by from a soldier, I guess. From Sailor, yeah. Okay, so keywords, the main keywords you can see here. The main keywords treasureship is relevant to this one. So using these keywords, you can come up with a good title also for this topic. Suppose you want to give a topic of this one, you can paste abstract or whatever, you can say that title. Entities. So entities is the name entities, what we have tried that. I'll make it big. So these are the entities. Person name is entity. Geographic feature is entity. Location is entity. Here, this is a location. So Indian George is a gorgeous geographic feature. Person name. Ivan's here you see here. Ivan's also person name. This is a combination. It's like Abdul Kalam. Albert, yes, Ivan's. The complete thing also person name. Two words are there. Lac, Kahulia. So this is also geographic feature. Two words are there. System should understand that also. Huntington Beach. Geographical feature. Okay. The next one is categories. You can see that categories actually, so where we can keep this document, the category, if you see that the travel, transports, sea travel. Travel, the suitable one is the travel is there, and the hierarchy, this is a hierarchical model actually. It's not only saying the travel, in the travel, transports, it's talking about the sea travel. So, or you can say that it's talking about the society and unrest and war. But the maximum score is for the first hierarchy. Concept of this one, you can see here the concept. So which I'm talking about the more. So you can see here. The syntax says about the morning we are seeing noun, the grammatical categories, POS categories. DET is determiner. It's adjectival of California. California is a proper noun. So proper noun. It's a name. It's indicating the name. So rugged is adjective here. You can see here. Buried is a verb. This is the dictionary form is buried. This is what I said that we have a 10,000 forms in our language. Fine. So any other clarifications here? Shall we move to next one? Next one. Or any doubts here? Participants? Can we move to the next demo? Hello?
Yes, sir. Yes, sir.
Okay, thank you. Thank you for the response. So the next one, if you see that, this is the example of GP2 model actually. This is called a GP2. It's called it's one kind of transformer generation. If you do the generating, this is generating model. So generation means if as yesterday I said that if you give 10 research papers, it will generate into one research paper. That is generation. So the same thing I'm going to do here. I'm going to pause some sentences. I'm going to generate them. You can see here, I'll just take the standard example here. Okay, Elon Musk, so I just given the sentence. So this sentence is given, the system is adding that. This system is writing that. The corpora may be available in their thing. So I'll just take a lot of the rings. So one sentence is given. You see that it will generate the other sentence. See that the goals and really advanced to the dogs raising the weapons with our city. A row wrong positive group faster together. This system is generating. So what I'm going to do now is I'm going to take on recent news article and I will just see that how the system is generating. So I'll take from One India news. Okay, I'll take a local language also. First, I will take on English news, and then we'll see that whether the system is giving a meaningful output or not. We can see that. So one sentence, if you are giving, the system is creating its own story. There are some systems actually, so it will generate songs automatically. Song lyrics, so it will generate automatically. So I'll just take one sentence and then I'll give. May not be meaningful actually, may not be meaningful, but relevance. Okay, sorry. This is generator. Okay, the sentence generator, the generate another. The Ministry of Home Affairs has allowed certain industries to use oxygen on a temporary basis. Okay, you see that it's talking something about oxygen next. They can use oxygen for manufacturing food, but cannot go higher than that. So loading that acceptable concentration. Oh my God, is it? It's talking something. It's like look like a say government is home ministry is telling something about oxygen. I don't know. The next sentence is same. However, subject to okay, but then here the next sentence is different. We don't know whether this the whatever it's generating is new or it's valid or not. But it look like it's a meaningful sentences are coming. Am I correct? The Home Ministry has allowed states to and UTs to issue no objection certificates to the industries to use oxygen. This existing sentence, this may be the true sentence. From somewhere it's taking the later sentence and then it's generating its own paragraph. Now I would like to try for another language. Which language shall I try? Shall I try for Telugu or Tamil or Hindi? Participants? So people anything okay. First I'll start with Tamil. So some Pichimani asked about Tamil. So I'll just give one sentence. Okay, I'll take one sentence. Then I'll give one. So one sentence I've taken. I don't know whether it will work or not. I don't know whether the model is developed for multiple languages. We'll see that. Yeah, it's generating. You see that. But the problem here is this is not a meaningful word in Tamil. This is not a meaningful word. It's a character-based model based on the character. It's generating something, but it's not. These are all not meaningful words. These are all not meaningful words in Tamil. So the model is not trained properly. I mean, not trained for Tamil. This is a meaningful word. The words are it's a kind of spelling mistakes are there. So I'll just see that. I hear that Hindi, it's somewhat it's working fine. I'll just give some Hindi word. I don't know Hindi, just to read and then say that whether it's generating any meaningful sentence or not. I'm taking some news. So these are all the old Tamil words. I don't know from where it's taking these words. So Hindi sentence I have given on Hindi sentence, we'll see that. Yeah, can anyone help me whether it's a Hindi, is it generating? Poonam? Can you say that whether this sentence is meaningful related to this sentence?
Yes, sir. Yes, sir. It is meaningful, sir.
Yeah. That's what they have Hindi model. They don't have a model for South Indian languages, I think. Completely meaningful, huh? Okay. Okay, shall we go to the next demo? Is actually the important one from Stanford University. Stanford. Yeah, so this is like the same thing we have seen actually. It will give IBM Cloud. It will give all the annotations actually. So you can see here. So here the type also you can use. So whether you are using the biological data, so I'm just selecting the NER data set. Here I have made that. So once again, I'm just getting on call. One second. I'll be back. Okay, so this is the text is given, and then what I want is actually the annotations. What are speech name entities, lemmas, dependency calls I want. So you can see here. So this is the information. Lemma we have seen, no activation. Cells is there, and cell is the lemma. Contain is the lemma. So like that. Name entities, and then the dependencies, dependent between the words it's giving actually. So you don't need to develop that. The stanza APIs are there actually. You can run a small Python script, and then if you pass some sentence, you'll get this output in a JSON format or other formats. So you can make use of it. So the next one is okay. ENT1. Yeah, this is again the name entity. It's only for name entity visualization. You can see here we have seen the name entity, person name, and then organization and product date and everything. Whatever you want, you can click that. You can see here. So here the sentence is given. This is the output actually. So this is a person name, system identified. Google is organization. We are saying about a date. So the American North is I don't know what is North. Okay, again the organization, but this is actually not the organization. Udacity is the organization actually. This is a person name. System made a mistake here. Earlier this week, date. A decade later, date. So this is an interesting one. So when someone messages you in the Google, someone mails you. So using this name entity, you can directly pass that information to your, save the information to your Google Calendar. But future, I think it will come automatically. If the system says that this is date and this is a event, if you click that, then that date, in that particular date, the event will go, and then the event will store in the particular date. Fine. So the next one, I'll just move to summarizer. I think someone asked about the doubt and summarizer. That's what I have selected this one. So here I'll just paste one piece of text. I'll take English text. I'll just take a small text and then I'll see that how it's performing. Sentence, what I want is I want to convert this into 2 sentences. So old one, you can see here. Okay, so it haven't summarized properly because the sentence is very small. So I'll try one. I'll open this. I'll try a 2 paragraph. I'll try and then I'll see to it. I want to convert into 2 sentences. See that doctors and healthcare staff are finding it difficult to work under the stress of violence. Healthcare violence have become, so only the first 2 sentences is given. So summarization is there, but not up to the mark. There are a lot of research need to happen in the summarization, particularly the generative type of summarization, where you need to generate your own sentences. The system need to generate its own sentences. Okay, next one is the hugging phase. Actually, this is the important one, where you can, the developing, when you are developing the model, you can make use of it actually. So the same, all the information I explained, the relation extraction, everything will be there. 4 NLP results are here actually. The advantage is this is like an API. You can call it as a library and then you can run it as such. So you can type any sentence here. Suppose I'll take one sentence and type here. Wait. Some sentence I have taken and then see that my name entity is geographical location, the geographical entity. I think this is India. It's saying that the top medical body, it's saying that it's something organization you are saying, and the relations are extracted here. Fine. So we'll move to the next one. Yeah, this is an interesting demo actually, where this is kind of a geographical interface. If you want to develop some tools, so you just make note of this bioNLP, or this is like a click drag things. So suppose I have a pre-trained model, you can make a pre-trained model here. This is like how we use a rapid miner. This is for NLP, particularly for bio. So if you want to remove the stop words, so you can link this. You can link this models. So like that, they have given a board model also. They are given here. You can see here. Clinical NER is given. Suppose you want to use the NER model, you can use the NER model. So no need to do anything from scratch. Here you can change the parameters, so and name and everything you can change. So this is like a click and drag, how we are graphical programming. So it's a blocks are there. First you are passing the pre-training model and classifiers like that. Okay, last one is actually this one, the bioNLP. So this is a demo for it's a demo for word embedding. I hope it's visible. So I have taken an English word embedding. So can you tell any word here? I just type some word here, and it will find out the nearest words. It's the power of word embedding models. I'll give a word of hotel. See, so you can see. So it's giving the words like hotels. Related words are given here. I'll give some words like Andhra. I'm giving, suppose you'll see that. Yeah. So state names are coming. You see here, Andhra Pradesh, Karnataka, Tamil Nadu, Maharashtra. So nearby words. So only corpus is given for training, but system automatically identify that and then it's generating that. And you can find out the similarity of two words also. See, for example, I'm just giving Rajasthan, and here I'm giving Rajasthan Royals. I want to find the similarity. These two are some more later, Rajasthan and Rajasthan Royals. It's a team, IPL team name. So suppose here instead of that I'm typing something like Delhi, okay, Mumbai Indians means, you see that. This is the old news, 2015 news actually. So that time Mumbai Indians is not there. I'll just type Mumbai cars. See that the similarity is less. Comparably, similarity is less. And Rajasthan, and then if you are giving completely unrelated word. So suppose I'm giving the word fish. So the similarity is too less, you see here. So Rajasthan, we can say that's famous for desert or camel. So I'm giving a camel here. So somewhat better. Camel, I think this is small. Yeah, reasonable is there. 16% similarity is there. And desert, if you see that, or I think I'll give a Sahara, I can give. Okay, fine. We'll see that. Okay, Sahara, the word is not there, I think. Fine. This is a explanation what I explained today morning about the word embedding. This is the output of word embedding. You can see here English Google News corpus we have taken, and then we are explaining. I'm explaining from that. And finally, word analogy. This is a little complicated to even the system is not giving better results here. The word analogy. There are a lot of open challenges here. Word analogy means we have seen example. For I'll say that king, and here you are saying king means man, and what about queen means? The answer what you are expecting is, I'm saying that king is man, and what about queen?
Woman.
Yeah, so we are getting the answer. See that? So there is a word analogic task. So, but it's very difficult to find out actually. But for few cases it will work fine, but most of the cases it won't work fine. For example, if we give fish and water, fish will be in water, and then if you give some other things, if you won't get the term land or something. I'll give something like India. India means I am saying that India means I am saying the capital. I will say Delhi. And what about Pakistan? The nearby. Okay, so I don't think in the first two results I'll get. Okay, the cities somehow it's getting Lahore, but Islamabad is not coming. 20 if I take, I'll get. So, okay. It's not there, but the important cities are there. Lahore and other cities are there. India, Delhi means Pakistan, I said that. Or I'll say cricket, if I say that cricket means, I'm saying cricket is means Sachin Tendulkar. And what about tennis? We'll see that whether we'll get any tennis player name or not. Yeah, the second one is a tennis player, and you can see here. Roger Federer's third one also. Sampras is there. Nagesh Bobadi is there. Nadal is there. System automatically, we are not giving any clue about what is cricket, what is Sachin, what is tennis. System automatically bringing that these people are somehow related to tennis. Okay, so this is the word embedding. Now I just I think I have few more minutes. So what I'm doing is I just take one code with the deep learning and NLP. Then I'll explain. If you have any clarification or anything, you can ask now related to that demo or anything else. Any clarifications from participants?
No, sir.
Fine. Okay. Oh, exams are there. Fine. When is the exam, sir? Today or? Okay. So whether the code is visible?
Yes, sir.
Yes, sir.
Yeah, this is called a collab. So if you want to parallel, if you want to execute, you can just type collab.research.google.com. So where what people used to ask actually, so there are a lot of dependencies, and then sir, whether we need a Ubuntu system to run this, whether we need GPU to run this or not. Here, Google is giving that platform actually. This is like a open share platform. So Colab, so kind of code lab, it's called actually. So you just type a code lab. So this is if you type a code lab and you will get a Python notebook. This is called this is a Python file. We used to call it as IPython notebook actually. So where the notebook means each code will be there. You can implement, you can run the piece of code, and then you can see, you can give explanation, or if you're if you want to see that what happening in each module, or what happening in each piece of code, where you can create this IPython notebook. This will be an interesting one actually. Here I just introduce, so due to time limit, I'm not running the code actually. I just explain the code. This is what I'm going to do is, the LSTM is nothing but it's one kind of RNN. Yesterday, due to time limit, I haven't covered the LSTM. It's a type of RNN. So I'll just say that how can you run the RNN and CM model for an NLP task? So I have taken the NLP task as IMDb. IMDb is a popular database I have taken here. It's a sentiment analysis data set. So we'll see that how NLP, what are the steps we require when you are approaching, when you are developing some NLP application. So this is the Python code actually. So I have said, yesterday I said the three important things when you are dealing with the deep learning model, the important framework, starting from Keras, and one is Keras, and the next one I can say that TensorFlow and PyTorch. Keras and TensorFlow are mostly used in a research perspective, but that PyTorch is PyTorch also nowadays people are using research also in the development side. If they want to develop any software or any piece of software using that application, then preferably people go for PyTorch. Okay, So this is just a like importing and the things actually. So you can see here, NumPy is a library where it's a Python library I used to for computation, numerical computations. So I have something called sklearn. Yesterday also I explained this one. The site it's called a scikit-learn. So where I'm using the I'm importing the scikit-learn to split the train and test data. So I'm going to have some data. Automatically, I'm going to split the data into train and test using the scikit-learn libraries. So the data set, in real time, I'm going to download the data set. So real time, I'm going to download the data set. So that is IMDb data set. So I'm downloading from the keras.database database repository. So model, what I'm going to try is a sequential model. So each step we'll see that what is happening, each step, that is sequential model. When you declare it's a sequential, then there won't be any break. So each step you have to declare and then the algorithm will run according to the sequence. So the other things are, what is dense layer, I explained, and then the convolution 1D. We have seen that you studied the convolution also, the convolution 1D, and max pooling 1D. We'll see that the LSTM, the RNN variations, dropout, and things, everything we have. The embedding. Today I explained embedding. So that is also the Keras default embedding we are using here. So all the things we have imported here. And our last one, callback and model checkpoint. Can you just guess what is meant by callback and model checkpoint from the term? Can anyone guess what is meant by callback and model checkpoint?
Callback is to represent number of epochs or increase or decrease.
That you can keep a epoch equal, you can make a epoch. Now, why we are calling it a callback and model checkpoint? In the callback library, I am just importing model checkpoint. You look at the term callback model checkpoint. Any answers?
In
As
case
it
your
is a
expected
LSTM
update-
model, how many previous nodes they have to travel back and continue from there like that?
This is not with respect to LSTM. For any deep learning, you can use this callback and model checkpoint. When
The
you are
checkpoint
training,
is the place from where it has to recontinue like that.
yes. So when you are training the model, so when you are tuning the model, suppose you are running for 20 epochs or 30 epochs. In one particular epoch, you may get the good results, good validation accuracy, less validation loss. But after some time, your accuracy may be decreased. You don't know because it's the 50 or 20, whatever the epochs you are giving, it's a hyperparameter. Hyperparameter or model parameter, epochs. Epochs is a hyperparameter or model parameter?
Hyperparameters.
Yeah, hyperparameter. So the 50, if you are giving, we don't know whether, because once if you are giving a 50 and then if you are not using this checkpoint or callbacks, system will run and then after 50 iteration, whatever the parameters are tuned, that parameter you will use as such in your testing model. But the model checkpoint, what it will do is, it will find out that which parameters or which epochs my model is giving good results. For that one, it will store as a checkpoint. So once you come back, after the training is over, once you are testing the system, it won't start the parameter tuned in the 50th epoch. It will start the epochs from the model checkpoint, where you are fixing the checkpoint. I'll explain that how to fix the checkpoint and what are the parameters. There are parameters to fix the checkpoint because you have to give some concern, you have to give some condition to fix the checkpoint, which accuracy I have to monitor. Whether I have to monitor validation accuracy or I have to monitor validation loss. So that is a parameter for the model checkpoint. I'll explain. So where we can use this model checkpoint is to callbacks. Not only if in that testing, when suppose you fix that model checkpoint now, tomorrow you are running the system. You can, instead of starting from the scratch, you can start from this model. That model where you stop, you can start from that model. That is the other purpose of this callback. So yeah, I'll share this. Some people are asking about the NLP, the demo link. I'll share that actually. And the chat box I'll share, or I'll share with the, once again. Fine. So I shared all the link. Just have a look on it. Fine. Okay, so that is the meaning of this one. Now you're just coming to the this. I hope you know the random seed. So you are just fixing the random seed. 7 means for reproductivity, because when you are going for a random split of train test, now I'm running the code. So the data may take a few data as a test set. Tomorrow, if I run the code, other few data it will take as a test set. So I don't want that. I want to continuously. I want, if once it's taken this as a test set, it has to retain that. So the same number has to reproduce. For that, I'm using this seed. Any number you can give. I have given a 7, so you can give any number. If I give you a 7, it has some parameters. 7 means it will take only some random numbers. It won't random numbers to the seed 7. From that only it will choose the train and test set. Fine. So now I just to go to the codes. The first one is I explained about the library and then the packages we are importing. Now I'm fixing the top words. Means that I'm going to consider only top 10,000 words in my corpus. My corpus may be big. So in that I'm going to consider only top 10,000 words according to the frequency of the words. Fine. Now I'm downloading the data set you see here. So this is the IMDb package. From the package, I'm just loading data. So I'm loading the data. So it means that, so this function will load the data and it will store the data to this 4 variables: xtrain, ytrain, xtest, ytest. So as I said that I'm talking about the sentiment analysis data set. This is a text xtrain and ytrain is label. Whether the text is positive or negative is the label. That is a ytrain. I'm printing the shape. You can see here I'm shape. Okay. After taking the train and test, I decided to go for a validation. So now the test and train I have downloaded from IMDb. Now I'm just converting the train data. Some piece of train data I'm converting, taking to for validation. So here I'm mentioning it's a 0.2 size. So here the variable is a test size. Actually, this is the validation. 0.2 means I'm saying the 20% data, 20% train data I'm taking for validation. My total data set size, if you see the train data, first train data, 25,000. So 25,000 is my data set size. Okay, my train data is 25,000. So in the 25,000, 5%, 20% I'm taking. 20% means 5,000 I'm using for validation. So this will be 5,000. You can see here 5,000. My testing data, as per this data set, I'm considering my test data also 25,000. 25,000 sentences for training, 25,000 sentences for testing. To tune the parameters, I have taken the 5,000 data taken from the training data. You can take from test also. That is what I have taken from the train. So that is what these lines are doing. Fine. Now I want to pad the input sequences. As I said that in NLP, one important thing is variable length. So the first text may have only 10 words. The next sentence may have 20 words. You cannot form a matrix properly. So what you can do is, first you have to find out some maximum review length. I'm fixing that. I'm considering 600 words is a maximum review. Only 600 words I can be considered. If your text contains 601, 602, I won't consider the 2 words. 600 I fixed. But some of the reviews may have only 2 words or 3 words. For remaining all words, what I'm doing is I'm doing the padding. I'm padding the sequences with the maximum length. So all the sentences will be now the size of 600. Now xtrain size is actually 600 words. And the xtrain is a 20,000 data points. So it will be 20,000 cross 600. This will be 25,000 cross 600. This is 5,000 cross 600. Any doubt or anything, just ask now and clear yourself. Is it clear? Size? Shall I move ahead? Fine. Okay. Now so far we have imported, we have downloaded the data, and we have converted the data to variables. See that I download the data from the repository, the IMDb is a repository, and I converted to variables. Now my xtrain consists of text. I think I have printed the xtrain somewhere. Okay, sorry, I haven't printed the xtrain. Okay, fine. Anyway, I'll share the code. If you want to just print and see that. So you can see that. Okay, fine. So the X train is just a text content, and X test also X means is the data point. Y is a label, 0 or 1 labels. Now I am deciding that embedding. So here I'm not using any pre-trained embedding. I'm planning for my own embedding. So I'm just initializing that embedding vector length. So I'm just checking that for each word I'm representing as 32 size vector. Each word 32 size. Here, how many words are there in the corpus? For each data point, 600 words are there. So now one data point is equal to 600 cross 32. So I hope you understand that this 32 is each word I'm representing to a 32 size vector. So 32 cross 600 is my data size, one data point size. Fine, embedding length I fixed, and then I just learned the embedding. So I have created I have created a model, naming it as a model. What I'm doing here is I'm just like how I explained in the demo. I explained, like the drop down boxes. You can click and then you can drop the boxes. Like that, I'm just now framing the architecture. So first I'm saying that this is sequential architecture. You go in a sequence way, it will go in a sequence way. I'm saying that. So in the sequential architecture, I'm saying that add one more layer, I'm adding the embedding layer. So the parameters for the embedding added top words. Because when I'm doing embedding, I'm supposed to do embedding only for that 10,000 words. I have given here the 10,000 maximum top words. If you are interested to use only 5,000, you can make it 5,000. But here the embedding will do only for 5,000 words. Remaining words it will leave. And next layer, embedding to the next layer. Embedding is it's like a parameter extraction, feature extraction. Next, I'm directly going to the LSTM layer. These are all the parameters of the LSTM. So these are all the LSTM parameters. 100 is 100 units I want. I'm asking. So whatever input you are giving to the LSTM, it will convert to the 100. And dropout is 0.2. So yesterday also someone asked about that overfitting in a deep learning. So that's the one reason we are using the dropout. The dropout is used for control the overfitting. So the system, if you are giving 100% of the data, as the network architectures are many layers on the complicated architectures, it will learn quickly, and it will try to get the maximum training accuracy. It means that a high overfitting. Instead of that, what I'm saying, I'm introducing a dropout. Dropout means in that 100% data, in that 100, suppose you have 100 variables, 100 data points means 2, I'm saying 0.2. So 20% I'm saying 20% you can drop. It means that even though the system goes for the maximum things, system you are dropping randomly. You are dropping 20% of the data. So it means that definitely system won't go for overfitting. So that is what the dropout means. So dropout is a kind of controlling parameter. Fine. The embedding is there. LSTM is there. Instead of LSTM, you can add CNN. The CNN means the parameters will change, or you can add simple RNN also. And the next one is a dense layer. So here I'm using the activation function. Sigmoid is my activation function I used. This is also a hyperparameter. You can use any activation. I'm using sigmoid activation. So finally, I'm compiling that. I want to back propagate the errors. No? For calculating the loss function, I'm using binary cross entropy. This is the most frequently used one. Binary cross entropy, and optimizer I'm using Adam optimizer. Okay. Now the everything. So please make a note. I'm designing the things. I'm not running the code now. I'm designing things. I have designed now because I haven't passed any data here. My data is extract. I haven't passed the data here so far. I'm just doing the design. I'm passing the data in a later stage only. So now I just designing that. When I'm designing, I design the embedding layer, LSTM, dense, and I'm compiling with the loss functions. Fine. So checkpoint also I'm introducing here. You see here. So checkpoint storage is the file path. Where I have to store the checkpoint? The file path I'm giving actually in HDF5 file. So you cannot open, you cannot see the model files. So it's encrypted one. Which one I need to monitor? So I'm saying that you concentrate on the validation accuracy. The validation accuracy is high in a particular data, in particular weight, you just store that weight. So that is what I'm just giving this information here. Now I'm going to fit in the model. So you can see here, this is before fitting the model, the architecture, you can see here, 600 words I'm having, each word size is 32. And then LSTM is 100 LSTM units I'm using. This data set is converted to 100, and then finally you are having dense layer of 1. So you want to find out whether it is positive or negative. So I'm running with that here, the epoch, I'm fitting the model actually with a, okay, fine. I have paused the data here, I think, where I paused the data. Okay, fine. Here, this is the model dot fit. Yeah, I'm fitting the model here. It means that so far I have designed the model. Now I'm going to fit the model with the data set. I have an architecture in my hand now. Now I'm going to pause the data. I'm pausing the train data here. Train data, X train and the Y train I'm pausing. And I'm pausing the batch size. What is meant by batch size? What is meant batch size? Any answers? What is meant by batch size?
Number of training records in
each iteration, can we say?
Yes.
So what you are doing actually, when you are in any kind of system, when you are pausing the complete data, definitely there will be a problem in storage, because whatever information you are running in your system, when you're executing, it is stored in your RAM. Definitely you don't expect you have that much RAM. So we are making it as a batch size, smaller size. So the system will take only the first 256 data points, and then it will run, it will update the weights. So it will keep on changing. First 256 data, second 256 data, like that will move. So that is batch size, and here I fixed it as a 5. So here, this is the architecture. You can see here for first epoch, you can see my loss is this one, my accuracy is this. This is the validation. This is the training accuracy, and this is the validation accuracy, and this is the validation accuracy. I said that I'm interested in monitoring the validation accuracy. I made the checkpoint to check the validation accuracy. So where I'm getting the validation accuracy? See here itself, you can see the best example is this one. The validation accuracy, see that after 5 epochs, after the third epoch, your second epoch, your third epoch, you are getting good results, validation accuracy. But later on, if you see that your accuracy, your loss is also increased, your validation is increased, your validation accuracy is increased. Now what you will do is whatever parameters you learned here, it will be updated by this epoch. The same parameters are updated here. So what you can do is the checkpoint will store this, and then the checkpoint, what it will do is it will monitor the validation accuracy, and it will store the parameters at epoch 3 in the checkpoint. So when you are testing the system, you start from the checkpoint. You upload the checkpoint, and then you execute the system. You can see here, you test the system. You can see here. Okay, this is the step where I'm going to evaluate the model. I'm going to pass a test set. So before that, I'm loading the weights. You can see here, weights, I'm loading the weights. I know that weights are the best checkpoints are stored in this file. I have given already the file name. Same file I'm taken, I just uploading the weights. The compiling function also I already declared that. Now I'm just evaluating the model. So I'm passing the test set. So test set I am passing like the test data I am passing here, and then Y test I am passing here. So my batch size is 256 I am passing here, and I'm waiting for the accuracy. So finally for this model, what is this 25,000? What is this 25,000?
X training data, sir.
X train or X test, ma'am?
X test.
X test, because our X train size is 20,001.
Okay.
So we have 25,000 test data. So this is the each test data. It took only 42 seconds actually. So the accuracy is, it's printing the accuracy 85.11. You have a Y test here. You have Y test in your hand. So you are calculating the accuracy. If you don't have Y test, and then you can print the Y test, Y predictor. You can make it as a Y predictor, and the system will give you the predictor results 1 or 0. It will give for the 25,000. So accuracy for the LSTM model is 85,000. Is it clear? Can I move to the convolution model? Any clarification here? So here the LSTM you can change. By LSTM you can use RNN. Anything you can use here. I'll share this code actually. Sorry, I couldn't run the code because sometimes no. If I run the code parallelly with you, this dataset size is I think 0.8 GB. So sometimes you have to download the complete data set in your system and you have to upload it. That's what I haven't run I haven't make it like a hands-on. So anyway, I'll share this code. You just make use of it, and if you have any clarification, you can contact me. Okay, now I'll move to the CNN model. So CNN also you have learned. Now what I'm going to do is I'm going to the combination of CNN and LSTM. So embedding layer, first I'm giving to the CNN. After CNN, I'm passing the pooling layer. And I'm passing the LSTM, then I'm going for the usual thing, dense layer and other things. So after with embedding, I'm introducing convolution here. So in NLP application, we used to always follow with the 1D convolution only. Because the data, you know, the data will be like a sequence. So data will be a words. If you are going for image, definitely you require a 2D convolution. So in case of text, if you are going, then you can go for 1D convolution. So the embedding, I already explained the embedding. Convolution, you'll see that what are things are there in the convolution. So convolution also have activation function. I am using the ReLU activation function here. So padding I am using same. Same is actually I haven't taken a class. I think you have learned as convolution. No, there is a concept called padding convolution. It's a little bit different here in terms of RNN. What convolution will do is actually when you go for 2-3 layers. So what the convolution will do is after 1 or 2, 3 layers, according to the filter size and the kernel size, the convolution of the input size will get changed. Input size will get changed. Someone raised the hand. Is there any doubts, Arena, or unknowingly you raised? Fine. Okay. So there is a padding option is there. So padding is same, and then padding is valid is there. Valid padding, whatever filter you are giving, according to the filter, the output will change. The output size will change. So, but here I'm using the same padding means I'm maintaining the same size. So because why I'm maintaining the same size? I want to pass the same data size to my LSTM model. So I'm maintaining the same size. So I'm using padding same here. 32 filters I'm using. The kernel size 3. What is kernel size 3 here? What does it mean, kernel size 3? Yeah, I'll finish it soon. So I'll just take a 5 minutes. I'll finish it. The kernel size 3 talks about say.
The kernel matrix used for the convolution, sir. That
yeah. Here the kernel size says about trigrams. 3 words we are taking. 3 words. First 3 words we are taking, and then we are combining next 3 words like that. Morning he explained, no, in a word embedding 5 words we are taking as a window of 5 words. Here it's a kernel means here window of 3 words in case of NLP. Okay, so the max pooling 1D max pooling we are using. So as we are using convolution 1D, so the pooling size is 2. You know what is max pooling? I think from 2 data points, two things we are clubbing together. The maximum value only we are considering. Remaining things are same. LSTM, dense, and compile. So we'll see the summary actually, the model summary. Size 632 we have taken. So as I said that I haven't used any, I have used the same padding. So I retain the same size. If I'm using here the padding value as a valid padding, then the value will be changed according to the filter size. According to the filter size, the value will change because when you are multiplying input and then filter, then the output will get changed. Here I don't want to change that output. And 632 is there. I'm using max pooling. Max pooling of this 600, I'm converting into 300 because 2 max pooling I'm using. So the 300 divided by 2. So it's a 300 cross 32. Now I'm using the LSTM layer. So I'll get only 100. That 100 I'm passing to the dense layer to get only 1 output. Here I'm using the same 5 epochs. What is this 20,000? What is this 20,000? 20,000 a trained data sets. Trained data sets. So here also I'm watching the validation accuracy. Here validation accuracy I'm getting 89. So I'm stopping my model here. I'm testing my model actually using the X test and Y test data. So see here what I'm getting actually, I'm getting my accuracy is 87.98. So my training accuracy is, sorry, my CN, only LSTM model accuracy is 85, but here I'm getting my accuracy is slightly improved, 87.98. So remember, whatever I explained here is a very basic LSTM and the CNN network. But if you want to add a few more layers, and then I explain different LSTM architectures, two layers, two convolution layers, you can change with the max pooling or into min pooling or global pooling or K-max pooling. You can go with a different RNN layers or attention. You can try n number of things here with the same code. I'll share the code with you, make use of it, and run and experiment your execute your application. Fine. Okay, so that's it from my side, I think. So I think I already taken a few more minutes. I don't know the time actually. So okay, fine. So now I'm stopping here. So if you have any clarification, you can ask now. Organizers, is it fine now? Yeah, participants, any clarifications or any doubts?
Sir, is this inbuilt function common to all the languages, or will it work for English alone?
All languages it will work, ma'am. Not only for this inbuilt function, the data loading part is for English only. So English data repository I'm loading.
Okay.
You can load your own data actually. That's a 2-line, 1-line extra code. You can upload your CSV file also.
In any language.
Any language you can convert. It will convert into X-train and Y-train.
Okay. Okay. Thank you.
Thank you. Any other questions? Any clarifications? Organizers, are you there? Okay, no problem. I'll share my email ID. If you have any clarification, you can ask. How to save file from Google Colab to local directory? Yeah, there is an option actually. So here you can see here local directory. Here I have given. I'm storing. No, here you can see here. Yeah, here I have given only the file name. I have given no. If you give your home directory, like this, I'll take your home directory in the next, just to say that. Documents. One second, I'll just take home directory. Yeah. So I just copied on our location, complete location link of my home directory. So I can paste it here. This is a file path. Will store the way it will store here. Like that, you can store your output also. Any other participants are interested in I think moving towards the exams? I guess I think fine. You just carry on. The organizers, are you there, or I try to call them? I guess.
So can this be applied for data like patient summaries?
Yeah, definitely, ma'am. You can apply for patient summary also. From patient summary, you can go. You can classify that what kind of disease they are having. You are passing only the summary, and then you want to identify that what is that disease, what kind of surgery they have undergone. That is also possible.
Thank you, sir.
I'll call the organizers once again. Sir, just now I completed, and yeah, participants are having. Yes. Oh, fine. I'll wait, sir. Shall I wait? Yeah, fine. I'll wait. Yeah, I'll be here. Fine, it's no problem. Okay. My God, 145 participants. Maybe 18 exams. Sir. Hello, sir. Yeah.
Now it's the time for valedictory. Now regarding this, I would like to call the convener of this FDP, the Dean R&D, Dr. T.R. Chaitanya, sir. Sir, you please. Sir.
So to all the participants and the faculty members, especially who are attending this 2-week FDP program, actually I'd like to extend my sincere thanks to AICTE for sponsoring this 2-week FDP program. And in general, the FDPs of this kind are very essential for the professional development of the faculty members. So, however, learning to teach is a lifelong process involving continuous improvement. So, being a faculty community, we need to update so that that is like I'll be telling everywhere, like when the faculty are ready, then we can make our students ready. So these kind of FDPs and the thirst areas. So Base Institute of Technology and Sciences always looking forward to organize FDPs and the thirst areas, and we'd also encouraging our faculty and other faculty members to towards the professional development of the faculty members. So I'd like to congratulate all the participants, and we have seen in the valedictory function, like it was like 143 participants are available, and all the resource persons are these online FDPs. So we can. This is the second FDP from AICTE we have conducted the last 1 year. So there was a huge response from the participants, and initially we thought that it may be a challenging one, and with the support of all the participants, we have everybody participated and make it a grand success. And I'd like to thank all my team, the co-conveners, HOD CSC, Srinivas Rao and Fani Kumar, who have taken a lot of efforts in making this FDP a reality. And our management, our secretary sir Sridhar Garu, then our principal Srinivasan Garu, and all other the leadership of the Base Institute of Technology are always behind us and encouraging us to go with these kind of FDP programs. And I'd also thank all my resource persons. Without them, it may not be possible. So all the big giants in the academia, so our team has taken a lot of time in pulling the resource persons and taking their time, and with the open hands, all the resource persons, they have accepted our invitation, and they have given us the time to participate in their lectures. So I'd like to thank RBV Subramanian Garu, Nandan Garu, then Siddharth Garu, then our internal team. Everybody have helped us to make this program a grand success. And we have seen a lot of overwhelming response from the participants asking queries offline. Even the resource persons are telling that. So people are there are proactive participants in this group of students. So it is really good interaction. Even in the last session, we have participants who have been interacting and getting benefited from these kind of program. This type of interaction will also encouraging us to go ahead and conduct more number of programs of this kind. So on an outlook, once again I'd like to thank AICTE for sponsoring this FDP, the participants, the resource persons, and our internal team. Thank you, one and all.
Thank you, Chaitanya sir. And a small announcement regarding examination link. Dear participants, actually, I posted the examination link in our Zoom class chat and YouTube live chat. But one of our participants, he posted that in our group. Then if we post that link in group, then there's no question of posting it in our chat. Here we are trying to reduce the participants who are not participated in this class. We want to reduce them because of they are giving first, not you. You are listening the classes, they are giving attendance, they are giving feedback, they are attempting the examination, getting the certificate. That's why here I am posting in chat. But one of our participants, I don't know who is that person and how it's date, I don't know. He posted that in group. That's why I canceled that one and I created a new one and I posted it in our chat. And again in live chat also, in YouTube live chat also I posted it. And before 6 p.m. here up to 6 p.m. it will be available. Then you please attempt the quiz before 6 and you need to get 80% of marks to get the certificate. And once you attempt the examination and you get above 80%, then you will receive your participation certificate to your mail.
Sir,
Okay,
can I ask one question, sir?
Is it clear?
Sir, can I ask one question, sir?
Okay. And
Sir, can I ask one question?
yeah, regarding what?
Sir, is 80% a guidelines of the FDP, sir?
Sorry?
Is 80% are the guidelines of the FDP?
Yes.
Because in exam 80% you are telling no, sir, for certificate.
As the guidelines of AICT.
Sorry, sir.
As the guidelines of AICT.
I think AICT guidelines is 60 or 70, I think so, not 80. 80% attendance is mandatory, sir.
Okay.
I subject to correction, I don't know, because there are nearly 140 participants available in the FDP. I don't know whether if 80% is mandatory, that is up to the management issue, sir. I don't want to comment on that.
Okay.
Thank you, sir.
We'll make it as 70 or 80.
We'll make it correct, no problem.
Yes, actually, the in this brochure itself, they had given us 80% attendance, and it is of the marks is of 60%.
Okay.
So I hope it would be 60%, sir.
Yeah, no problem. I will make it correct, no problem.
Okay, sir. Okay, sir. So kind of you. Thank you.
We'll make it as correct, sir. No problem. That is, I will make it
Sure, sir.
around 60. Around 60.
Yes, sir. Yes, sir.
Yeah, is there any doubts other than this? Yeah, 60% is okay. I modified it already.
Okay, sir.
Now, if you have say 60%,
From the side of participants, we thanks a lot for the greatest sessions you have organized for us, and we request for more programs like this in the future too, sir. Thank you. Thanks a lot.
Thank you, sir.
The resource persons are very nice and they explain many concepts very clearly, sir. So I thank the organizer for making such a wonderful thank you.
Thank you, sir.
Thank you, sir.
Anyone wants to give a feedback?
Thank you, sir.
and all the participants, you please give the feedback first.
If you want to
attendance,
you can
and attempt the quiz.
You want to give a feedback orally, we welcome you. No problem.
And once again, I will share all the videos from session 1 to session 10. Day 1 to day 10, all the YouTube videos we are having, all the videos I will post in your group. One WhatsApp group, I will post everything. And once after 6, I will make give a chance in the WhatsApp group to chat the participants also. Now I disabled it at present because of somebody are posting whatever the links I am posting here. That's why I disabled it. Once after 6, the examination is completed, then I will give it. And who are having link, who are having link and again unable to complete the examination within the time period, if they ask me, and I will give a chance. But I won't post the link again in WhatsApp group. Here, I already post the link here. You please make it copy and it with you, and you can take the time up to 6 o'clock. That means 2 hours I given. Then in between that, you please complete the examination. And once again, thank you very much for selecting our FDP. And again, the long period, 2 weeks, almost 10 days. You all, mostly I think all of you participants are patiently listened. And again, mostly around 80 participants are daily with all sessions from starting to ending. You are attending here and you are listened, and again you are interacted with the resource persons. And here it is a great thing. And I also participated in so many FDPs and again organized some of the workshops and FDPs. They are like this here. These type of interaction I want to see up to now. From here, from day 1 to day 10, here all the participants, most of the participants are asking the questions from the resource person and getting the doubt, clarify the doubts from the resource persons. Here it's a great sessions, and I would like to say thanks again to all the participants and the management, the principal sir, the convener of this program, Dr. T.R. Chaitanya sir, and the head of the department, Dr. M. Srinivas Rao sir, to given this opportunity to organize this FDP and make it a success. Thank you once again.
Thank you, sir.
Yeah, I would like to thank the organization, PACE Institute of Technology and Science, for arranging such a wonderful and resourceful 10 days faculty development program on machine learning and AI in data science for us per day. Very excellent session we had, sir. In each and every session, it made us learner to learners. So excellent talk was given by all the resource persons. So even I have seen, that is, I have realized among the resource person, there is a competition in sharing their expertise and their knowledge and intelligence and transferring it to us, that is the learners, to think brilliantly and made the research mind to think, rethink, repeat in finite loop and transfer the learning to find the new idea. Hats off to all the resource persons, sir. And every day session gave us the feel of attending the normal faculty development program in online. So we forgot we are attending in online. Okay, so we are attending in offline. So all the session are very, very excellent session, very, very informative. And once again, I thank the institute. You arranged the session for us during this period, sir. Thank you very much, sir.
Thank you very much, ma'am, for giving your valuable feedback.
Really, I thank the organizers who have chosen these resource persons of with high knowledge, and they have given hands-on session also. It was very nice, sir.
Thank you, ma'am. Thank you very much.
Thank you, sir.
Yes, sir. I too agree with Jai Chandra madam. Because as of now, we have been treated as a faculty members, but in this FDP, first time we were treated as a students, because the resource persons are waiting a response from us. Unless we give the response, the resource person is still waiting, even it is not right, even it is wrong. Just please try to respond. So like that, the motivation that I got, really it is very much impressive. So I want to thank from bottom of my heart to especially Funny sir and HOD CSC sir, so making this program more success. Thank you so much for introducing these type of knowledge resource person, sir. Thank you so much, sir.
Thank you, sir. Thank you very much.
Thank you, sir.
Sir, this is Dr. Dara Vikram. I feel very happy to participate in this FDP 2-week program. Really, I observed because I did my research in data mining, data warehousing, and the way all the eminent personalities as the resource persons, everything was very good. Really, I learned a lot. After a long time, I found this was the best FDP. Thank you, Management Pace Institute of Technology. Really, all the efforts are all admirable. Thank you so much.
Thank you,
Yeah,
sir.
thank you, Vikram sir.
Thank you, sir.
Yeah, once again, thanks to all the participants to make this FDP a grand success. Thank you very much. And you please attempt the examination. And after 6 p.m. here, I will give access to post the chart in our WhatsApp group. If you have facing any difficulties, you please post on that. Except the link. Except the link, I will give any thing for you. I hope you understand. If I post it, then anyone
Need
can
a
do it.
material also, you can post it in the group. So you need not worry about the PPTs, all these things. So we will post it in group.